Today we're going to talk about the section 6.4, the use of inverse functions. Words you should know. An inverse. So a regular relation or function, you put in an input and you get an output. Inverse, we're going to change those things. We're going to change the x and the y. If you have an inverse function, when you compose the two functions, that is, you put one in for the x of the other, you'll get x. This second fact, the inverse function in the compositions, we're not going to use that so much now. It becomes more important next year. So example 1, find an inverse relation. So in order to do this, step 1, switch the x and the y. So I'm going to go to my function over here, and where there's an x, I'm going to put a y, and where there's a y, I'm going to put an x. Step 2, get y by itself. So I'm going to add 5 to both sides. And I'm going to divide both sides by 3. So I now have y equals x over 3 plus 5 over 3. And that's my inverse. If your inverse is a function, you can denote that with this f. And then it looks like you have an exponent of -1 of x equals x over 3 plus 5. X over 3. That little -1 doesn't mean it's a negative exponent. We're not taking the reciprocal of anything. It's just to denote that this is the inverse function. The relation is a function here. So you're going to try this in your notes. I'm going to give you a minute, pause this recording, and try this on your own, and then we'll go over it. So now we are going to work out this problem. Step 1, switch the x and the y. Step 2, get y by itself. Two over 4 is going to simplify down to 1/2. So our inverse relation is this. If we were going to denote that this is a function, and an inverse function at that, we would write it like this. Okay, in order to verify that two functions are inverses, they give us a function, and they say, is this second part its inverse? So what we're going to do is we're going to find the inverse of this first one, and if it is the same as what they ask us, then yeah, they are inverses. So we'll go about the same process. Switch our x and our y. Remember, f of x is y. Get y by itself. So y is x over 3 plus 5 over 3. X over 3, that's the same thing as pulling a 1/3 in front of it. So yeah, these are the same. Which means, yes, they are inverses. We're done. Again, I want you to try the next one in your notes. You're going to do the same exact thing. You're going to find the inverse of the first one here, and if it is what you get over here, then they are, in fact, you have verified that they are inverses. So give it a second, see what you can do. Okay, so we have we've tried that out. So let's see if you guys get the same thing that we're going to get here. So step 1, switch the x and the y. Step 2, get y by itself. So we will get y equals x over 4 minus 1/2, which again is the same. So yes, these are inverse functions. Moving on, we are going to look now at what happens if we're going to do this with something that is not linear, something that now has an exponent. So, find the inverse of f of x. X is going to be greater than 0, and that will be important later on. Then graph f and the inverse of f. So step 1, let's find the inverse, because that's what it says. Find the inverse. Step 1, find the inverse. Step 2, graph. Got to make sure we're doing all of it. So we'll switch x and we'll switch y. To get y by itself, I'm going to have to take the square root of both sides. So take the square root of this side, take the square root of this side. So I am going to get y equals plus or minus the square root of x. We have an even index, so it will be plus or minus. Looking at the original equation, though, or the original problem, it says that x has to be greater than 0. So since x has to be greater than 0, the inverse of f is going to be just the positive square root of x. Because x has to be greater than 0, x can't be less than 0, which would be negative. So step 1, we have our inverse. Step 2, it says graph. Well, it's been a while since we've graphed a quadratic. So let's see what we can do. Y equals x squared. It's because f of x would just be this part over here. So x squared, it's not being shifted at all. It's not being stretched at all. This is what we've got. This is our normal, everyday parabola. And then it's asked us to graph the square root of x. We haven't learned how to do that yet. That's actually the next section. But it's going to be our f of x, but it's going to be rotated here. It's going to be rotated over the line y equals x. So it actually is going to look like it's being flipped down on its side here. So this will be the inverse of x. If it could be less than 0, it would be down here as well. But as of right now, we have f of x is here in the yellow, and we have, I'll make that pink, the inverse is over here in the pink. Try the next one. Keep in mind, like I said, you're just going to be rotating this for the inverse. So find your inverse, graph your original parabola, and then rotate it in order to get the second one. We'll get a little bit more precise with that in the next section. Give it a try. Try in your notes. So let's see how you did. So find the inverse of this. So we're going to switch our x and our y. We need to get y by itself. Take the square root of both sides. Since it has, it says again here at the top that x has to be greater than 0, we are only going to deal with the positive portion of this. So our inverse is going to be square root of x plus 2. On to the graph. And let's see again what we remember about our shifts with these. So for our parabola here, we now have a plus 2, so it's not just our standard parabola. That plus 2 means we're going to move this graph up 2. If you need to verify that on a calculator, you can, but it's going to look like this. So when we shift it, it's also going to be over 2. And again, we're just going to have the positive portion. So this is f of x, this is the inverse of x. How do we test whether a function is how do we test whether a relation is a function if we have its graph? Well, we know this parabola is a function. This parabola right here is a function because it passes the vertical line test. So we can draw an imaginary up and down line, and it's a function. We learned that a while ago. So this is a function because it passes the vertical line test. For inverses, we have something called the horizontal line test. The inverse of a function f is also a function if and only if no horizontal lines intersect the graph of f more than once. So if we have a function, here's our function, this one's a pretty cubic, its inverse will also be a function if it passes the horizontal line test. Horizontal line test, see, passes, therefore it is the inverse will be a function. Something like a parabola, unless we set limits, the inverse will not be a function. So, vertical line test. Tells you f is a function. Horizontal line test tells you if the inverse of f is a function. So both these lines here, they're functions, they pass the vertical line test. But if we were to find their inverse, this one, because I can move this horizontal line up and down, and it always passes, so the inverse of this one will be a function. The inverse of this one will not be a function. They don't give us any practices on this, so we'll take a look at that on your math Excel. You'll be given some graphs, and you'll have to say whether or not their inverses are functions. The last thing we're going to do is we're going to take a look at the graph of a function and see if that graph can tell us whether or not our inverse will also be a function. Then regardless, we'll find our inverse to see, just to find our inverse. But we could have an inverse that is a function or a relation. So let's see. Let's plug this into our calculator, and I'm going to do this on Desmos just because it'll be easier for you to see on the screen. But you could do this on your graphing calculator. So we have 2x cubed plus 1. So y equals 2x cubed plus 1. So there's my graph. I'll go this way. So looking at my graph, this passes the horizontal line test. I can draw imaginary lines all sorts of places here. And it's always just going to pass in one place. So that inverse is, yes, the inverse will be a function. So because horizontal line test, inverse will be a function. Okay, now let's find the inverse. Now that we know the inverse is a function, let's find it. So same steps as before. Put x in for y and y in for x. And let's get y by itself. Divide both sides by 2. Take the cubed root of both sides. So since this is an odd index, we aren't going to have to do our plus or minus. So we'll just draw our little 3 there. And we will have x over 2 minus 1/2. And that is our inverse. Okay, last one to try on your own. Give it a shot. Pause the video and take a second. Hopefully the first thing you did was put this into your calculator to see whether or not the inverse was going to be a function. So 3x to the 5th minus 2. So I'm going to go to my calculator. 3x to the 5th minus 2. And there's my graph again. It goes up and down forever there. So let's look, I'm looking, it's gonna pass the horizontal line test. Anywhere I'm gonna draw this line and I can move it up and down, it's only gonna touch in one place. So the inverse of this will also be a function. So we'll abbreviate a little bit more this time. So per horizontal line test, inverse is a function. Okay, so now we need to find the inverse, and now we can say inverse function because it is an inverse function. So we're going to switch our x and our y. So we have x equals 3y to the 5th minus 2. Add 2 to both sides. Divide both sides by 3. To get y by itself, I'm going to have to take the 5th root of both sides. Since the degree is odd, it's not going to be a plus or minus. So we are just going to have x over 3 plus 2 over 3. Okay, so now you have some practice to work on, and we will talk about this next class. Good luck.